This is something that you're going to want to know how to do or be more comfortable with than maybe had we not done this for a full year. So, our different exponent rules. So one of the things I want to mention is when we're talking about a value that has an exponent, like something like this, so like 5x to the 6th power. So I want to talk about what everything stands for. Bless you. So the 5 here, we're going to call that the coefficient. So that's considered the coefficient. What power does that coefficient have? What's the power on that 5? It's not the 6. What's 5's power? It's not x. Guys, Simon, why don't you go move into that, please? What's 5's exponent? It's a 1. So this has an exponent of 1. So any number, so like 5, like if you paid $5 for lunch, you could say I paid 5 to the 1st power for lunch. You wouldn't say that, but 5 has a power of 1. We just don't write it. It's assumed it's there. So that coefficient has a power of 1 currently. Now the x we're going to call our base. And so this is the number that's attached to that exponent. So this one has an exponent of 6. Now, obviously the exponent can change, and so obviously 6 then is our exponent. We can also call it a power. So when I'm referring to these words, I'm hoping you know what I'm talking about. And again, this is something that we haven't done for a while. This is algebra. So this is something you probably learned like 2 Januaries ago. Like, I mean, it's a while ago. So we're going to talk about multiplying monomials. And monomials are single terms. And so what that means is all these are not going to have addition and subtraction typically. They're just going to be multiplication and division. And like sign changes and stuff like that. So we got to remember our different rules when it comes to these multiplying monomials. So I have like a general rule here. We're going to kind of explain what we're doing here in this case using that. And then I have an example. And again, it's just going to take a bit to jog your memory with this. And maybe the example is the easier one to start with. Anyone have an idea how they would explain this to someone that doesn't know it? And we might be that someone right now, but anyone have a thought on it? We've learned this before, so I don't want to steal your thunder. Yeah. We add the exponents. So this is like x to the n plus m. Very good. So we add the exponents of like bases. Now, real quick here, guys, I got to make sure it's clear that we are going to test on this chapter. We're probably not going to put it on the exam, though. So when I'm saying we're reviewing, I'm probably not going to put it on our semester exam, but I will put it on a test. Yep.
Isn't it like you multiply the x, like say there were 2 different numbers, like 2 and 3, once you multiply the 2?
So like in the next example?
Yeah, like that.
Yeah, we'd multiply those. So yeah, so we're going to add the exponent of like bases, and then we're going to multiply what we call the coefficients. Yeah, so that's what you were talking about.
Yeah.
So we're going to multiply these coefficients. So the -4 and 5 are just normal numbers. Don't overthink this. So sometimes people think, I added the exponents, so I should probably add those numbers. Those are just regular numbers we're going to multiply. So -4 times 5 is going to be a -20. And then x to what power? You're going to do 3 and 6 together, so that's the 9th power. And again, this is something we did last year, and I'm hoping you guys remember it. And if not, that's why we're reviewing it. But again, walking in Mr. Hatfield's room, I don't want you guys, if you're taking Algebra 2 next year, I don't want you to say, gosh, I vaguely remember exponents. It's probably going to be a little bit better if we review it now. And I just want to show a quick example of why this rule works the way it does. is the reason we add the exponents is because x squared is really x times x. X to the third is really x multiplied 3 times. So we end up with a total of 5. So like that's kind of the long way to do this. I just don't want to have to write out how many x's there are each time. Okay, questions there? So we're going to go into our dividing of monomials. So we did multiplying. Now we'll do dividing. And again, these lessons, this like little half sheet probably took us like 3 or 4 days in algebra. But again, I'm hoping since we've learned this before that we don't need 3 or 4 days. So now with dividing,
Subtract.
yep, so it's the opposite operation. So we're going to subtract the exponents of like bases. Now I will tell you guys, we want to avoid negative exponents. So we're going to subtract the exponents, but we're going to talk a little bit more about this. A lot of times when I do this, I ask the question, where are there more of whatever variable we're talking about? So we're going to think about it that way. And same thing with like, before we multiplied the coefficients, now we're going to simplify or divide the coefficients. So in terms of, let's start with the coefficient on this one. So this negative 2 over 8, we're just treating it like a normal number. So like think about 2 out of 8 slices of pizza. How much did we, like what's the total amount? What's that going to be?
No, 6. Wait. Is it negative 2 minus 8?
We're not subtracting it, we're simplifying or dividing the coefficients. What's that? What's that? 1/4. 2 out of 8. Think about it back to like again, pizza. 2 out of 8 would be, that's a fourth of a pizza. So this is a negative 1/4. So those coefficients, we treat those like normal numbers. Simplifying. Now the exponents is where we have to subtract. But again, I don't want negative exponents. So if I did 2 minus 6, I would end up with a negative exponent. So the way I ask this is I say, where are there more x's? And then how many more are there? So I look at this x to the second over x to the sixth. There's more on the bottom. How many more? There's 4 more. So 6 minus 2. So I'm going to put an x to the fourth on the bottom. That way I can avoid those negative exponents. Okay? How about the y's? Where are there more y's? On top, how many more? 3. And so this would be our simplified version of that. So again, hopefully this is kind of coming back to you, but again, we're trying to break up some of those misconceptions, some of those things you guys are saying, which I don't mind you guys like saying out loud the wrong answer because it's probably something somebody else is thinking as well. But we have to kind of set the record straight, I guess. So we're going to flip the page over, and we're going to get through the rest of these notes, and then we'll probably just do some practice with some whiteboards. And again, all our homework this chapter is going to be worksheets, so we don't need our textbook at all with that. Again, we can check those back in if you're interested to do that, to get rid of that out of your locker ahead of time. All right. So negative and 0 exponents, and then we also have a third rule, is power to a power. So there's 3 rules here. So it says x to the 0 power. Kind of same idea if I did like 5 to the 0 power. Do you guys remember what that is? It's not 0.
So it is number 5?
Not 5. It is 1. This is always going to equal 1. So any value to the 0 power is going to equal 1. And you might not care about this, I had a student ask why is that. So I use the x to the 0 as an example. If I have x x to the second over x to the second. Technically those should cancel to be just the same thing on the top and the bottom. So those would cancel to be 1. But if I do 2 minus 2, that's just 0. So that's x to the 0 power, which ends up just being 1. So definitely a kind of weird concept, but if you check this one in your calculator should give that to you correctly. Now negative exponents are a little bit strange. You guys remember how to make those positive? You flip it where it is in the fraction. So currently this is on the top. So I'm going to drop it to the bottom and make it positive. So x to the negative n power is really 1 over x to the nth power. So let's do this first example here. We'll go to a power in a second. So when I'm doing a problem like this, I kind of ask myself, does it have a negative exponent? Does it have a 0 exponent? Can we simplify anything there? So negative 3 is fine. Negative numbers are perfectly fine. It's negative exponents we don't want. So negative 3 is not the same thing as 1/3. But this m to the negative 2, since it's a negative exponent, I'm going to drop it to the bottom. When I move it into the fraction, it's going to become positive. So it just switches its spot in the fraction. And then the n to the 0, we found out that just equals 1. So it's really like 1 times that. So this can just be rewritten this way. So our last rule, and then we'll do a couple of examples, and like I said, then we'll grab whiteboards for a little bit, is power to a power. And what I need to do with this is I'm going to multiply those powers. So I multiply the exponents. But I have to distribute that power to all bases inside the parentheses. So I'm going to multiply these, but I'm going to distribute that power to all bases inside the parentheses. So we're going to do that example down below, and then the example to the right kind of has some of everything, so it's like a next level question there. So I'm going to take this negative 2 power and I'm going to distribute it in. Now the thing is though, I have to distribute it into both this power, but then also, like remember I said before, like the 5, it really has like a 1 as its exponent. So that negative 2 also has to go to the 5. So it's going to become 5 to the negative 2. And then x, I'm going to multiply those. Negative 2 times the negative 3 is going to be the 6th power. Now, we don't like negative exponents, or math people don't like negative exponents. You might not say, you'd probably say you don't care about negative exponents one way or the other. But the math world, and we want to have the lingo down, we're going to have no negative exponents. Currently, this is all on top. So anytime I have a negative exponent, I'm going to drop its position in the fraction, or change its position. So this is going to become a 5 to the 2nd in that fraction. But the x to the 6th is going to stay on top. So each base is kind of independent of the other ones. And then I'm going to simplify this a bit, because 5 to the 2nd is pretty easy to do. It's not some crazy, 8-digit number. So I can just write that as x to the 6th over 25. All right, so our last problem we're going to do here on the notes together, and then like I said, then we'll do some whiteboards. I want to give you at least 15-20 minutes for homework, so I'll save that time, but Let's do this one and then we'll grab some whiteboards. So we still want to do order of operations. So parentheses are most important, but I want to, there's nothing really I can do inside the parentheses technically. So I'm going to distribute this third power into everything inside. Now careful, it's got to go to every base, including top and bottom. So the 2 is going to get it. So all of these are going to get that power. So I'm going to kind of rewrite it down here just because I won't have enough space otherwise. So the first fraction, I'm not going to change it yet. Our second fraction, power to a power, I have to multiply. So that's where the 6th power comes from. And then the bottom, I'm going to have a negative 9. 3 times 3. Now the 2 fractions might be throwing you off. Don't let them scare you. Fractions just really can become one big fraction together that we can just multiply. We don't cross multiply, that's for proportions. So we can just multiply across the top and the bottom. So, now if you remember, Nathaniel mentioned the coefficients before. We treat those like normal numbers. So these, the big numbers in the front, we're just going to put those together. But this is a negative 3 times 2 to the third. Well, 2 to the third is 2 times 2 times 2, which is 8. So negative 3 times 8 is a negative 24. So I'm choosing just to get those coefficients out of the way. Now we're going back to like kind of the front side of our notes. Our exponent rules with addition or with multiplication. So I have this a to the negative 2 and this a to the third. It's just going to be a to the first or just a. So if you want to write the first power, you can. So he just added those together, negative 2 plus 3. So our next thing here is our b. So I have b and b to the 6th. Like a b to the first and a b to the 6th, so b to the 7th. I just added those. And then on the bottom, I'm just going to put those together. I could move them right now, but I'm going to leave them where they are right now. I'm just going to put them together. Negative 2 and negative 9 is negative 11. So once you kind of do these problems in terms of like kind of breaking things down a little more slowly, I don't think they're as bad. But if you try to like look at it and be like, I have no idea what to do with that, yeah, it looks overwhelming. So hopefully breaking it into smaller parts is helpful. Now I have this negative exponent on the bottom. So it just like it moving it to the bottom, changes its sign, moving it to the top does the same thing. So that's now going to go on the top with everything else. So it's become positive on the top. And now again, the negative 24, we're fine with negative numbers, just not negative exponents. Okay? So, I'm going to have you guys grab whiteboards, markers, and erasers. I'm going to grab them quickly for us. So you guys want to come grab one, you can grab one for partner as well.
Kind of hard to write on other markers. I got you.
You really not gonna grab it? Grab a damn whiteboard. I like it. Yes, you're welcome. This one's white, this one's white. They got me. I want to hear the blank.